Fly ash waste management. Energy has come to be known as strategic commodity, and any uncertainty about its supply can threaten the functioning of the entire economy, particularly in developing economies like India. India's substantial and sustained economic growth is placing enormous demand on its energy resources, and coal plays the most important and pivotal role to account for 55% of the India's energy need. Our Honorable Prime Minister Shri Narendra Modi has led a roadmap by setting a target to produce 1,500 million tons of coal by 2020. As Indian coal has ash percentage up to 50%, that is highest in the world, it is estimated that about 500 million tons of ash will be generated per year to meet the energy demand of the country. Earlier, fly ash was treated as a waste, but we Indians need to change the mindset to treat fly ash as a non-hazardous byproduct in line to the valued observation of Environmental Agency of Japan. The new guideline of Ministry of Environment and Forest in India has directed all the thermal power plants to use 100% of fly ash within 9 years of its commencing operation. This enforcement has put a technical and research drive to explore all possibilities of using fly ash gainfully so that fly ash is not considered as a waste in India. Now about the model. The present model depicts a conceptual model of using fly ash in different industries as a valued input material. That is a fertilizer plant using fly ash as an input material. The recent scientific investigation suggests that fly ash is found to be one of the best fertilizer to ameliorate the soil biologically when combined with cow manure, pressed mud, paper factory sludge, farmyard manure, seaweed sludge, crop residue and organic compost. Real-life example, a case study. In Kottayam district of Tamil Nadu, the villagers are using fly ash generated at Neyveli thermal power plant regularly and has observed the soil fertility and vegetation has increased significantly. Earlier, Neyveli lignite management was finding difficulty in disposing the fly ash, but now villagers are requesting the management to provide fly ash to be used at their farming fields. The villagers noted that the crop production and yield has increased significantly. This shows the crop cultivation in a rural part of the country. Fly ash can also be used for manufacturing of building bricks using the suitable technology developing in CSIR laboratory. Our current clay brick production exceeds 100 billion bricks per year. In such circumstances and when fly ash bricks is technically utilized, it would support in producing at least 2 billion fly ash bricks per year. It would consume about 5 million tons of fly ash per year, yielding a net saving of around ₹20 crore per annum. Fly ash bricks have a number of technical advantages over conventional burnt clay bricks. There is an urgent need to create awareness among the people so that more bricks manufacturers come to forward to use the technology, and the government has to encourage the use of fly ash by framing special incentives for this purpose. That shows the highway. Fly ash can be used for the construction of road and embankment. It is scientifically observed that soil mixed with fly ash and lime increases the load-bearing capacity of the road by 84%. National Highway Authority of India, that is NHAI, is currently using 60 lakh cubic meter of fly ash and propose to use another 67 lakh cubic meter in future projects. In view of growing need of development of road and infrastructure in the country, conservative estimates show that about 15 to 20 million ash can be used in construction of road and flyover embankment per annum near thermal power plants. This would yield a saving of around ₹100 crore per annum. The fly ash can also be used as an input material for manufacturing distemper and enamel paint. This research trial has been done in the Valley and demand of white cement for decorating interior surface has reduced. The performance of distemper and paint made of fly ash is very satisfactory and can be manufactured at half of the price. This is a cement factory which uses fly ash as an input raw material. The fly ash is also used as an input material in ceramic industries, glass industries, which is required for the building of modern India to build cost-effective houses. Fly ash can also be used as a filling material in underground mines. In this way, the surface structure can be protected and fly ash can be disposed successfully too. The research has shown the fly ash can also be used as a zeolite to purify the unclean water so that it may be reused. This has been shown in the model over there, where the wastewater is getting cleaned by fly ash and is reused gainfully. This will help in conserving water and minimizing water pollution. At the end, I wish to conclude that this model successfully demonstrates the use of fly ash in various industries gainfully. Thus, scientific waste management has resulted into converting the treatment of fly ash as a waste to a valued input material and byproduct. It is estimated our country will save Indian rupees 5,770 crore per annum by scientific and proper use of fly ash in manufacturing of fertilizer to increase crop production, zeolite for water waste management, in brick industries, ceramic industries, glass industries, paint industries, distemper industries, road construction, mine road fillings. This model has made an attempt to showcase the 100% utilization of fly ash in India in various industries. Thank you.